Hi, hello. Today we shall be developing panel co-integration model and finally panel VAR model. Okay. And here we have two variables. One is export and the second one is import. We have these two variables. So variables are here. I can show you all the variables. They are here. Just 1 minute. Sorry. The variables are here. I can show you. Just 1 minute. The variables are here. It is here. You can see. Okay, these are all variables I can open for you so that you can see as open as a group. Okay, open as a group. And here in this model there are 6 countries and the data from the year 2000 until 2010. So here are 6 countries. You can see from here. Country 1 is here. You can see this is country 1 and the data is from 2000 until 2010, and this one is the second country, that is 2, and the data from 2000 until 2010. Then this one is the third country, country 3, then country 4, country 5, and the country 6. We have the 6 country and the data are here, export and import data, right, of 6 countries. Okay, now okay, now what I do, here in this model I assume that these two variables such as export and import, they are non-stationary at a level, but when I convert them into first difference, then they become stationary. That I assume. As a result, I have fulfilled the condition of panel co-integration model. So I can run the panel co-integration now because they are non-stationary at a level, but when I convert them into first difference, then they become stationary. Okay, now I first start with the panel co-integration. I go to quick, then I go to group statistics and Johansen test of co-integration. Okay, first I put my first variable, that is export and import for 6 countries, and here these two variables are non-stationary, that I assume, but when I convert them into first difference, then they will become stationary. Okay, here I write export first, then I write import, right? That I do first. Okay, make sure export is first, import is second. Okay, then I am set. I proceed. Okay, here you can see the panel desktop co-integration, and here are 3 three method. One is Pedroni, Cow, and Fisher. Okay, out of three method, suppose Cow method is our benchmark. On the basis of Cow method, we shall decide whether our variables are co-integrated or not. So I select Cow, right? Then I select here lax selection. I select automatic selection. So I am set, I am ready, I can proceed. Okay, so this is the outcome. Cow test of co-integration, and null hypothesis, no co-integration. That is the null hypothesis. And here you can see T statistics and the corresponding probability. Probability is 9.07%, which is more than 5%, meaning that I cannot reject null hypothesis. Rather, I accept null hypothesis, meaning that there is no co-integration among our two variables, which are export and import. There is no co-integration. Okay. So as a result, I can run the VAR model, not VECM model. Okay, I can run VECM model when these two variables are co-integrated. But here I can see they are not co-integrated, meaning that I should run VAR model only. Okay, then we check again. Again the same thing. Okay, last time I put export first, then import, but this time I shall put import first, then export. Okay, I proceed quick as before. Group statistics, Johansen test of cointegration. Okay, this time I put import first, then export. Right here, import would be the dependent variable, and export would be independent. So that is my model now. Okay, I check also this one. I press OK, and here I use the cow as a benchmark. As before, I press OK. Yes, the result has come up. The null hypothesis, no co-integration. ADF statistics and probability is 5.48%, which is more than 5%. So I cannot reject null hypothesis. Rather, I accept null hypothesis, meaning that there is no co-integration among these two variables, meaning that there is no long-run associationship between these two variables. Okay, as a result, we can run the VAR model, panel VAR model, and that we shall do now. Okay. Okay, how to proceed? Actually, there are two ways to estimate panel data. There are two ways. So I am telling from here. There are two models in the panel. One is fixed effect model, and number two is random effect model. Okay, and I shall estimate both. Then I shall check which model is appropriate, and as a result I shall use the Hossain test to check which method is appropriate. Which method? Is it fixed effect model or random effect model? Okay, so I proceed with this one. Okay, first I estimate fixed effect model, then random effect model, then Hossain test. Okay, I proceed. I go to quick, right? I go to quick, then estimate equation. Okay, here, so this one is the VAR model, that means there is lag. So here I assume that, suppose there are two lags should be optimum, that I assume. Okay, first I take export as a dependent variable, right, in the VAR model having 2 lag, because 2 lag, when I take 2 lag, the value of Akaika information criteria become lowest, that I assume. So as a result, here I am taking lag 2. Okay, so here I am setting the model like that. Okay, export, so lag 1, then export lag 2, then import lag 1, then import lag 2. This is my model, you can see. Okay, so I have to double check. Export 1, export 2, import 1, import 2. I'm double checking. Okay, so and here is no error correction term, because because the variables are not co-integrated, so there is no error correction term. Okay, I think I am set. Then I go to panel option, right, and the first I shall estimate fixed effect model. So I select fixed, right, I select fixed, and other thing okay, then proceed. Okay, sorry, what is happening? Something wrong here. Double check. Export. I think it is here. Some problem is here. Should not be any gap. Okay, I think now it is done properly. Okay, I proceed again. Panel, fixed effect, right, that I select here, then press OK. Yes, the result has come up. This one is the fixed effect model when export is the dependent variable. You can see export is the dependent variable. This is the fixed effect model. Okay, now I estimate the random effect model. That I do now. I go to estimate. Okay, so everything remain unchanged, right? It is remain unchanged. Okay, then I go to panel option. So this time I take the random effect model, that I select, then press enter. So this one is the random effect result. You can see dependent variable is export, and this one is the random effect model. Here you can see cross random effect. Okay, we have estimated two model, fixed effect model and random effect model. Now out of these two model, which one is appropriate? And the Hossain test can answer this question. Okay, so what I do, I go to view, then I go to fix random testing, and here is the test Hossain test. You can see from here, right? I select it. So this one is the test of Hossain, and cross section random chi-square value and the f stat and the p value. P value is how much? Okay, p value is 0.0627%, right? That is the p value. Okay, what I do now, okay, in this test, what is the null hypothesis? I check. And what is the alternative hypothesis? Here p value is 6.27%. 6.27% means we cannot reject null hypothesis, rather we accept null hypothesis of this Hossain test. Okay, and here what is our null hypothesis? I check. Null hypothesis is null is random effect model is appropriate, that is the null, and alternative hypothesis is fixed effect model is appropriate. Okay, and here and there I could not reject null hypothesis, so I accept null hypothesis, meaning that random effect model is appropriate. Okay, so I estimate the random effect model again, because that one is the most appropriate. So I estimate it. Where is my things? Okay, so I estimate the random effect model from here. Estimate. So this one is here already. Panel option random, it is already here. So press OK. So this one is the random effect model, that is the most appropriate. Okay, now I can check the causality. That means whether import can cause export or not. That I want to check. Causality, or I can say joint causality from import to export. Okay, and so here you can see one thing in this EVIEW. In this EVIEW, the first one is C1, second one is C2. I come here, it is C1, it is C2, C3, C4 and C5. So that means here are 5 coefficients. And here what I want to check, whether import lag 1, import lag 2 jointly can cause export or not. Okay, here import 1 means C4 and import lag 2 means C5. Okay, so here I can do the world statistics to check. World statistics. Okay, I go to view, then current coefficient diagnostic, then world test, it is here. Okay, my hypothesis would be C4 equal to C5, are they equal to 0, right, or not? That is the null hypothesis. Okay, if they are 0, that means import lag 1, import lag 2 jointly cannot cause export. Okay, we check our result now. I press OK. So have I done any mistake? I just double check. I think we are done. Okay, it is the wall test, and there are F statistics are here. F statistics value and probability all are here, and null hypothesis C4 equal to C5 equal to 0. So the probability is how much? 2.63%, which is less than 5%. So we can reject null hypothesis and can accept alternative hypothesis, meaning that C4 and C5 is not equal to 0. It means that import lag 1 and import lag 2 jointly cause export. That means there is a causality running from import to export. So that is the decision of this model when export is the dependent variable. Okay, now I check what happens when import is the dependent variable and export is the independent variable. That I check, and we have seen that these two variables are not co-integrated, so we can easily run VAR model having lag 2. Okay, then I proceed with our things. Okay, I proceed. Okay, I go to our models work file, right? Okay, so I proceed with the VAR model as before. Quick estimate equation. Okay, this time import is the dependent variable, then constant, and it has two lag 1, lag 2, then export export lag 1, export lag 2. I think we are set properly. Import lag 1, lag 2, export lag 1, lag 2. Okay, here as before, first I shall estimate the fixed effect model, then I shall estimate the random effect model, then I shall estimate the Hossain test to check which model is appropriate as before. Okay, suppose first I estimate fixed effect model, right? Okay, I think I am set everything properly. Okay, then I go to panel option, then I select fixed effect, right, as before, press OK. So this one is the fixed effect model. This one we have fixed effect model, this one. Okay, then I estimate the random effect model now. How? I go to estimate this one as before, then panel option, I go to random effect, then press OK. So this one is the random effect model. You can see random effect. Okay, now the thing is that out of these two model, which model is most appropriate? We shall use the Hossain test as before. I go to view, then I go to here fixed random effect testing, then Hossain test, right? I select this one. Okay, this is the Hossain test, cross section random, probability is 0, right? So and what is our null hypothesis? Null hypothesis is random effect is appropriate, and alternative hypothesis fixed effect model is appropriate. Okay, this time we can reject the null hypothesis and can accept the alternative hypothesis, meaning that fixed effect model is appropriate. Okay, so we estimate fixed effect model. Now I go to estimate. So this is my model, right? This is my dynamic model because there is lag. Then I go to panel option, but I select fixed because fixed effect model is the appropriate according to Hossain test. So I am set. I proceed. Okay, so this one is the fixed effect model, right? Okay, so this one fixed effect model. Okay, now I just double check, just 1 minute. Okay, it is a fixed, yes, fixed model. Okay, now I check that whether there is a causality running from export lag 1, export lag 2 to import. Here import is the dependent variable. As before, it is C1, C2, C3, C4 and C5. So as before, so I can set the same hypothesis whether C4 equal to C5 equal to 0 or not, as before. And here I shall use the world statistics as before. I go to view, then coefficient diagnostic, world test, it is here. I put the thing C4 equals C5 equal to 0, that I set, right, as before. C4 C5 0, then press OK. So that is the outcome. Just 1 minute. Have I done anything mistakes? Just double check. It is becoming how much? Becoming wall test, becoming okay, so here is the wall test. Result of the wall test, you can see F statistics. Probability is 27.03%, which is more than 5%. So we cannot reject null hypothesis, rather we accept null hypothesis, meaning that C4 C5 equal to 0, meaning that our export lag 1, export lag 2 jointly does not cause import, meaning that there is no causality running from export to import. So that is the outcome of this model when import is the dependent variable. And thank you very much for being with me. Bye.